So 9-5 is today. I've already got one. Thank you.
Where's
Ty, I've already got one. Thank you.
Yeah. Todd's not even here.
Yeah, we're going to start without them. They had plenty of time, so they'll catch up when they get here.
Doesn't that mean they get like a late return pass?
Not a pass. Means if it becomes a habit, we'll take care of it.
Time to start.
All right, so you remember our track superstar, Johnny, and he wants to support...
He looks different every time. Hey, I didn't get one for myself.
Yeah, these are things that should be taken care of before the start of class, not after I start class. You've been in here for multiple minutes. So, our star athlete, Johnny, he wants to support the Friday Night Math Club because we all know that the best way to spend Friday night is by doing math. So, Johnny goes to the Friday Night Math Club fundraiser, and he decides he'll buy 2 coffee mugs. If you can't see it, the coffee mug says math is number 1. It's supposed to be kind of a pun because number 1 is it's not fun. So, they want to raise more than what they raised last year. Now, last year, the Friday Night Math Club was able to raise $40.25. So we want to know how many more mugs, not counting Johnny's 2, how many more mugs do they need to sell in order to reach this goal? So if we write this out in a verbal statement, they want to sell or make or whatever you want to call it more than the $40.25 that they made last year. Now, have they sold anything so far? Didn't Johnny buy some?
Yeah, he bought 2.
Yeah, so our sales or what we have to sell, we've got Johnny's 2 mugs and then whatever else we buy. So Johnny's 2 mugs together are worth how much? $7. So they've already sold $7 and they will continue to sell multiple more mugs at how much a piece?
7.
Not $3.50. Each one is $3.50. And then because that's going to happen over and over and over again for every mug they sell, we can multiply it by the number of mugs. And that's going to be greater than the $40.25. Yeah.
How did you get the 3.50?
Because that's the price per mug.
So,
Each mug they sell is $3.50. So this 7 is because Johnny already bought 2 mugs. Those are the only mugs they've sold so far. We want to know how many more mugs they have to sell.
okay.
So since Johnny already bought $7 worth of mugs, they are $7 closer to their goal. We on both sides get rid of the 7 by subtracting 7. Because they have sold $7. They're that much closer to their goal. Then I'm going to move over here. That leaves us with $3.50 times M is greater than $33.25. So now, what are we going to do to figure out how many mugs? Todd?
I had a quick question.
Okay.
I forget what that means, but when you say 3.50 times M, I forget what the symbol means.
This is greater than. You want to read it left to right. And remember that the gator always wants to eat the bigger number. So this value must be bigger than that value. So you can say greater than is bigger than is more than. I mean, there's lots of ways we can say it.
I thought it was 33 because, it's a higher than.
But we don't know what M is. Because remember, the 3.50 is going to get multiplied by M. So what we're saying, and this is a great question, what we're saying is what does M have to be for this to be true? For that number on the left to be bigger than the number on the right, what does M have to be? Or what could it be? Because there's not just one answer, there's many answers here. So what do we do to get the M by itself? What do we do on both sides now? Alpha?
Divided by 3.50.
We divide by the $3.50, or the coefficient to my variable.
On the first side, you get left with M, and the second side, you get left with 9.50.
So if I get 9.5, m has to be greater than 9.5. We want to say a realistic statement about this. So we could say they need to sell 10 more mugs. Because is 10 greater than 9.5? Yeah, could you sell half a mug?
Yes.
I mean, you could try, but I doubt anyone's going to buy it.
My teacher.
So they need to sell 10 more mugs
My teacher has a
or more. Because is 11 greater than 9.5? Yeah. Is 20 greater than 9.5? Is 600 greater than 9.5?
No.
Yeah. We have tons of options here, guys. We literally have infinitely many options, or at least until they run out of mugs. Alpha?
Last grade, our teacher had one of those. Like he had a mug that was like cut in half, and it was like.
So I know what you're talking about, but if I take the Mr. Estes type of question for that, is it really half of a mug, or is it just a mug that looks like a half? Because it would still be a mug, right? It still holds coffee.
Yeah.
Like, so it was like this, but straight on one side, right?
Yeah.
So
Yeah.
is it still a mug? Would that be half a mug, or would that still count as a whole mug? That's one of those philosophical questions.
Like software and everything was expensive, so I could only afford half a mug. That's what he said on it or something.
Yeah. All right. Does this situation make sense?
Yeah.
All right. Good to hear. Moving on, we have, I'm going to teach you guys how to be the math teacher.
Yay. I would love that.
Can't use my phone today.
So when I write your guys' tests, I don't start with a question. I start with an answer. So here's an example. If I were to start, ignore what's on the board right now, if I were to start back in last chapter when we were dealing with equations, say I want you to get that the answer is 5. I know we're going to use 5 up here, but just ignore that it's an inequality. But I don't want to just, get you to the answer real easy. So I first say, well, what could I do to both sides? Well, I could, according to my property of equality, add, subtract, multiply, or divide as long as I do it to both sides. So the first thing I might do would be, say, multiply 3 on both sides, and I'd get 3x equals 15. Could you then solve this to get x equals 5? Yeah, like you know how, right? The next thing I could do to make it even harder is say 3x plus 7 equals, what would my right side have to be now?
15. No.
It would have to add 7 also, and it would become 22. So when we work to build an equation or an inequality, not to solve it, but to build it, you can do whatever you want to both sides as long as you do it to both sides. A lot of people forget to do it to the right side. They'll do it to the variable side, and then they'll forget. Now, on your homework, it phrases things like if you apply the multiplicative property of inequality, which says if I multiply on both sides, it stays an inequality, or if you apply the addition property. So it's telling you what you're doing, whether you're multiplying on both sides, adding on both sides. It goes through and lists out. And if we have time, we'll look at a couple of the example or the problems from tonight's homework. So we want to first write a 1-step and then write a 2-step inequality with x greater than 5 as your answer. So I would, if I was you, draw a little line beneath that so you can split and have a 1-step and a 2-step. Can anyone tell me one step that they want to do on both sides? Huh?
We're actually right this on it.
Yeah, this is on your notes. It's that first example. Can anyone tell me one step that you would do to both sides that then you could undo to get your answer x is greater than 5? I need somebody not alpha. Otherwise, I'm just might as well be having a conversation with alpha. Lainey, what do you think? What operation are you feeling like today? Add, subtract, multiply, divide. Multiply. Sure. What number do you like? 5. Sure. So if we multiply on both sides, think about starting here. But Lainey just told me I'm going to multiply by 5, and I'm going to multiply by 5. What do I get then? Well, my left side becomes 5x. What's my right side become? 25. Then, to work this backwards and solve it, we could divide by 5, and we would get our answer, so we know that what we did is correct. We want to do the same thing, but we want to make a two-step inequality that equals x is greater than 5. So actually, to make a two-step, we can just take our one step and make it a little bit more complicated. So I'm going to start with 5x is greater than 25, but I'm going to do something to both sides now. Ty?
Subtract 20.
Sure, if we subtract 20, then the inequality I get is 5x minus 20 is greater than, what's my right side? 5. We would then first, to solve it, because we want to check if we did this right, we could add 20 to both sides. So we always undo addition and subtraction first. That would give me 5x is greater than, well, now I'm back to 25, and then when I divide by 5 on both sides, we get the answer that we want.
It's just not that hard though. How do you know which number to guess for the first one? Like
We're not guessing, we're determining. So like I just asked Lainey, when we can do whatever we want, ask yourself, what operation do I feel like doing? What number do I feel like using? And you just have to do it to both sides. Now, if you're building a two-step, this is where it gets dangerous. When you're building a two-step, you have to do the operations when you're building it in the order of PEMDAS. So if you're going to multiply and then subtract, you have to multiply to the variable first, then subtract to the variable. You would not want to subtract to the variable, then multiply, because then you'd actually have to use parentheses, which you can, but that just makes it even harder. Then it becomes like a three-step.
So my homework will be like questions.
So like a problem I helped somebody with earlier was, given the inequality, like x is less than 3, they said, what would you get if you first applied the multiplicative property of inequality, which says multiply to both sides and it stays an inequality, with the number 9. So the first thing they did was make it 9x is less than 27. Then they said, then you apply the subtraction property of inequality, which says if I subtract on both sides, it stays the same, and the number 6. So this then became 9x minus 6 is less than 21 because they subtracted 6 on both sides. So that might be, that's like an example of what you'll see on your homework. It tells you what to do. It tells you what numbers to use. You just have to then choose the correct inequality. Huh?
For the x greater than 5, is that I say it?
Yeah.
I never know how to say that.
Yep. X is greater than, bigger than, more than.
How did you get the 5? Do you just like...
It started. It gave it to me.
No, I mean like, how do you know to like, sorry.
Are you saying how did we get this 5?
Yeah.
That one Lainey just chose.
Okay, you just choose a random
Yeah.
number.
When you choose, well, unless it tells you what number to use. Like on your homework, it'll tell you on some of them to use like multiplication and the number 9, or division and the number 4, or you know what I mean?
Oh.
So if it doesn't tell you, then you can just do whatever you want, which is why writing math tests is pretty fun actually. So try this out. I want to challenge you to write a 1-step and then write a 2-step. So again, I would draw your line. Your 1-step, I would always, at least for me, I would use multiplication or division, because then to make it a 2-step, you just have to put in an addition or a subtraction. Your solution has to be n is less than or equal to 8. If you are having issues, please stick up a hand. Or a foot, or... when you're looking to make your one-step inequality, we start with n is less than or equal to 8. What did you do to both sides?
Wait, is it less than or equal?
So it's either. It's n is less than or equal to 8. Because remember, we have the less than or greater than. We have less than or equal to, greater than or equal to, equal, and not equal. Those are all our symbols. So we're using the less than or equal to. So n might be 8, or n could be less than 8. So it could be 7 or 6 or 5 or 4, any of those, but it might be equal to 8, it might be less than. But all you have to decide is what operation do you want to use and what number do you want to use. So I'll make your choices easy. Do you want to multiply or divide? There's no wrong answer here. Multiply, sure. What number do you like today? Don't listen to the peanut gallery.
I have a question.
8?
Yeah.
Let's not use 8 just because it's already a number that's up here. 7? All right, hold up. Hang on to it for a second. So, Alex, we then multiply to both sides by the 7 that you told me. Yep. And then that becomes 7n, or 7 times n, make sure you're writing this down, is less than or equal to 56. What was your question, Ty?
Wouldn't there be a wrong answer to pick an equation, multiplication or division? Wouldn't addition be a wrong answer?
So you could add first. It just makes it more complicated. So there really isn't, or like, so I could, you don't have to write down what I'm going to write in green. I could, Ty, say n plus 5 is less than or equal to 13. So if I take 8 and add 5 to it, then if I want to multiply, I would have to multiply the whole thing by whatever I want to multiply by. This would then become 3n plus 15 if I distribute is less than or equal to 39. So I still have just multiplication and just addition going on, but because I did the addition first, it makes it a bit more complicated because we have to distribute. If I do the multiplication first, then when I add, I just add over here and I add over there.
I did the 7. Can I do the second one? Because I did.
So here's our one-step inequality. This would take one step to solve. We would divide by 7 on both sides, and that would get me my answer, n is less than or equal to 8. So then if I take the 7n, I can just do something else with it.
Subtract it by 50.
Sure. We can, I mean, there's really not a wrong answer. You're just doing whatever you feel like. So if I subtract by 50, my left-hand side is 7n minus 50 is less than or equal to, I have to subtract by 50 over here,
6.
equal to 6.
Yes. And then you do the plus 50
So
Yep.
on
plus,
the homework, there's no answer, really?
Oh, there is, because on the homework it gives you more specifics. Right now we can do whatever we feel like with just these first examples.
I feel great
Yeah.
about this one.
Wouldn't 8 minus n is less than or equal to 0 be also an inequality? Because then you have to
You would have actually added 8 to both sides and multiplied by -1. So yes, because if you multiplied first by -1, you'd get -n. Ooh, but you'd have to flip your inequality actually.
I feel great about this lesson.
Well, we're still in part 1, so hang on. All right, so now we get to real life situations. Salesperson has a job, and they're debating between getting a new job or sticking with their old job. Now, here's the thing. You never know necessarily what your bonus will be when a bonus is contingent. Do you know what contingent means?
Continue. Oh, never.
Yeah.
So contingent, like my mom, she works like contingent.
Yeah.
So like you do it like if you're working, they kind of like just call you whenever they need you.
Yeah, so it's like as needed.
Yeah, you don't go in every day or part time. It's just
Yeah.
when they need you.
So this situation is contingent because it's contingent on the money they make in sales. So their bonus only happens if they make money in sales. Yeah.
Like, this is just an example. Like my dad's friend, Tom. He's like, he works with he's like a locksmith.
Oh yeah.
He's like
Yep.
on call.
His current job, he's making $54,000. The new job he's looking at only starts at $35,000, but there's a bonus at the end of the year. Everything you sell, you get 18% of what you sold back as a bonus.
Wouldn't the circle bonus though? Because that's telling us what to do.
Yeah, if you want to make that green.
If I were him, I'll stick with the old one.
So, that's not what we're deciding. What we're deciding here is how much would he need to sell in order to make more. So we want the new job to make more than the current job. So I'm going to really small here, put new is more than current, because we want his new job to make more than the current job. You always want to make more. So the new job starts at $35,000. But you also get your bonus. We want that to be greater than $54,000. Now, how do I represent that bonus, the 18% of sales? Braden, what do you think? To represent 18% of sales of something that I don't know. Or did you just get back in here? Sorry, I was just looking at cards. Mia, what do you think? How do we represent 18%? Before I can do math with it, I have to make it. Hey, so when I ask somebody specific, it's really rude when you don't give them time to answer. So knock it off. We do write it as a decimal. So this becomes 0.18 for 18%. So that's going to be 0.18. But that's 18% of, what's of tell me to do? Multiply his sales. Yeah, we can use S. If you do, be careful, because some people's S's look like 5s.
True.
So if you use S, just make sure you make it nice and curvy. Now, what do we always have to undo first?
Addition.
We always undo addition or subtraction. Now, here's the thing. We have addition, but we don't want to undo the 0.18 because this is actually multiplying. The addition is happening with the 35,000. That's where people fall into a trap. Is they say, oh, what's added? And they look after the addition. Remember, addition order doesn't matter. So we can rearrange the order. 35,000 is actually what I have to start with getting rid of. So we get rid of 35,000 from both sides. That'll give me 0.18 times S is greater than
29,600. Negative.
what? I think you typed in something incorrectly. Because this should be 19,000.
You're real good at catching stuff.
Hmm?
You're real good at catching stuff.
Thanks. I also taught this once already today.
Speaking
Oh,
of new
and
jobs,
some
I'm also good catching your mistakes too.
So, now to get the S by itself. Nick, what do we do?
Divide by 0.18.
Yep. Divide by the coefficient to the variable. I'm going to write that again. And we get that his sales would have to be more than 105,000 $555, and the fives keep going. But because it's money, we round the last one up. Now, what type of job would it be really difficult to sell $100,000 worth of merchandise in a year? Ben?
McDonald's.
Yeah.
Think about jobs where you get maybe bonuses for what you sell. I've talked about a job that I had a lot.
Not Colson.
Is this your first job?
No.
This is like my 12th job or something crazy like that. It's my first teaching job.
I know it. What was your other one?
Where did I work that I talk about a lot? Do you know?
JC Penney.
Macy's selling jewelry. Now, I've sold some expensive jewelry. Stuff that I'll never buy because it's too expensive. At least I probably won't ever buy it, won't ever be able to afford it. But not $100,000 worth of jewelry. Now, I've got a friend who in a year could easily sell $100,000 worth of what he sells. But he doesn't sell jewelry.
He sells cars.
He sells cars. So when you sell cars, Ty pays attention. When you sell cars and each car is $10,000, you'd only have to sell like 10 cars. So if you sell one car every month, you'd make this much in sales. In a year. Well, depending on the price of the car and all that stuff. But if we say on average, let's say a car costs maybe $10,000, because some are more expensive, some are less. Yeah, you sell a car every month, you'd make more than that. Huh? Well, that adds to his salary. His salary is $35,000 plus a bonus of 18% of the sales. So this is what he would have to sell, not what he'll make, but what he would have to sell.
To get
Like my dad, like he works, he like sells houses and stuff.
Oh yeah, that too.
Yeah, so he makes like
So he could sell this much in one house. But doing real estate, you don't get a bonus. Like, that's not how things would work with real estate. With real estate, you pretty much only make money if you make sales. If nobody's buying houses, you're not making money. Same thing with CarMax, where my buddy works. He only makes money if he makes sales. So this job, what's nice about it is you make money no matter what, but if you don't make sales, you make less money.
For real estate, like after you sell a house, do you automatically get the money?
It depends on how things are written in the contract and how that real estate agent has things work.
So which job would you have gotten?
Huh?
Wait, which job would you have got?
Don't know. Probably another teaching job. I was tired of jumping job to job. I've worked Boy Scout camp, lifeguarding, Macy's, Sears, Jimmy John's, Old Navy, Otterbein, another Otterbein job, another Otterbein job, if you want to count that one.
That's 3.
I substitute teaching. I think I worked a couple more.
And you're teaching life.
Yeah, so I'm almost at a dozen. So,
Mr.
all right, try this one. Salesperson, Ty. I'm gonna chop your hands off, Brett.
Oh no.
So, a salesperson saved $375.80. That's in their bank right now. They, every week, now this is pretty good, every week she earns $865 in her paycheck. She takes 10% of that paycheck and deposits it into her account. So she's already got the $375.80, and every week she's depositing 10% of her paycheck. Now what we want to know is how many weeks will it take her to have more than $1,000. So if I was starting this, I'd write it verbally first. I want to have saved more than $1,000. I want to have saved more than $1,000. No, because we're going to be solving for how many weeks. I'm going to use W for my variable. Ty?
Are we going to be counting the weeks that she already has in her savings account?
Nope. For all we know, that came from somewhere else. This is just what she's making every week and able to deposit. So do we know how much she deposits every week?
Yes. in some way.
What do you mean?
We have to make 10% of what she earns, so she will constantly earn the amount she earns every week, but we just have to take 10% of that.
So unlike the last problem, Ty's exactly on. He's like A game today. Unlike the last problem, we had a percent of something we didn't know. This percent, this 10%, goes with the $865. How do you find 10% of something? We just,
We
well,
move
you
the
could
decimal.
You just move the decimal one place. So do you know what it is?
I know that it's 0.10.
You're right, but when we move that decimal, each week she's depositing $86.50. So, knowing that, can you set up the inequality to find out how many weeks it will take her to have more than $1,000? Try this on your own.
I got it.
So instead of making me the the 8, like I'm on my A game,
Yeah.
and I be the B team.
Sure.
Thank you.
But you're the best B team, man. Your socks, man.
Ooh.
Funky socks.
B team.
Yeah.
That's cool. You don't have any funky socks on. You're not part of the funky sock club.
Socks.
What are your socks look like? Oh yeah, good idea.
My socks.
So, W's are unknown.
Shoes.
W should be multiplying by the amount we're making every week. Gentlemen, I want to see some work on your paper, please. Think about what we already have, the value that we're starting with. We add with that some amount that happens every single week, over and over and over again.
I made a mistake.
Mission
So,
lesson.
we already have that much. We can start with that much. And then add, and you don't have the 8650 right now, you could already leave enough to the side here.
Oh, so you can.
That's
So you can take.
every week.
So you can take the 375 plus 86.
Yeah, because she's already saved the 375.
Mission lesson.
Yeah.
When you subtract something, does the 8? Because I'm trying to subtract 865. Like, would that go like back towards the decimal or like?
Trying to
Like in
subtract
front of you.
8. What? Why?
Okay, so look at it. I'm trying to do this. Subtract. What you got? 865.
Why? Because that 865 is not what she puts in. She only puts in 10% of that. So what she actually puts in is the 8650. That's what actually gets put into the account.
Oh,
Just turn it down.
So here is what we should have set up. The initial amount of $375.80 plus the amount that she puts in every week.
86.
Wait, wouldn't you have to work 4 extra? Or 4
We don't know. We're building this. We're getting there. So she puts in $86.50, but since that's every week times W. Because I do not know how many weeks. That's what we're solving for. Gosh, we have some people absent today. If you're sick at home, feel better.
Who's absent? Haley.
Whoever's watching this video.
Ashley and Ben and other classes, people were like, just stay healthy, take your vitamins, don't cough on each
I
other.
take vitamins.
Mr. Eisel,
That's advice.
what would I do first here?
Subtract the 375.
Yes. Ben jumped right over the trap, did not fall in. A lot of people will try to subtract the 8650, but that's not true. It's multiplied. We need to subtract the 375.80, and we do that from both sides.
That's 0.
Now we get, on the left side, just my 8650 times W. That multiplication is the only thing left happening. My right side, you got it?
I wanted to do the next part, but it's 624.2.
Yep. 624.20. Go ahead. What do we do
Okay.
next?
So it's pretty simple. We're just going to divide by 86.
We divide by the 8650.
Consideration real quick.
Hold up, let us get our answer. So then W has to be more than anybody.
9.
Is it just 9?
No.
Well, it's
9
8
point something.
Oh,
I
don't
don't
give me
have a-
point something.
I don't have a calculator.
415.
Well, there's a rack of them in the back.
I know. I'll get
Calculation
it.
time.
6. Now I don't trust you.
Calculation time.
It's like
Is it 8 point something?
Yeah, it's 7.22 if we round.
Yes.
So, realistically, how long will it take her to have over $1,000?
9 weeks. Well, 10 weeks. Wait.
8 weeks.
8. Anything more than 7.22 works. So her answer, how long it could take her, in 8 weeks, she'll have that much money in her account. Yeah. Check your math. Check the subtraction that you did it correctly, and then check that you did the division correctly.
Was that the answer?
I did 375.
I got it right.
First off, you forgot a decimal there. Just second off, you cannot just keep adding to 8650. That's why we have to multiply. You need to quit writing so big because you're running out of space and you can't fit the whole thing. This should all be starting as close to here as possible so that you can fit everything you can, because that's why you're so screwed up. Because that now looks like a 7. That doesn't even look like a 0. You see how that looks like a 7? You need to fix this one. So I either go post it and just rewrite it on there. You go fast, man.
Okay.
Guys, if I write it down, you should be writing it down exactly the way I am.
I got the answer right. But I forgot to round, so instead I have 7.21.
It's okay, because then anything more than that.
So it could
But
have been
since
8.
most people only get paid once a week, it would take her 8 more weeks of pay. Or 9, or 10, or 11, or anything bigger.
I want a job where I get paid for that day. Like,
Now, revenue is a financial word. Revenue is the amount of money that a company receives for selling their goods or providing services or whatever. Anyone know what profit is? If you did Phoenix Fair, you probably know. Nick?
It's like the amount of money you make, and then you subtract the amount you spent making it.
Yeah, so profit is the revenue, and you want to write this down. Profit is the revenue, the money that they make. Oh, I heard that they called somebody, but yeah, you can go.
And my mom just texted me that she
Okay. Have a good day. It's the revenue minus the cost. So the cost, whatever you spent to make your, like, did anyone in here do Phoenix Fair? What'd you do?
I tried to.
We made hand warmers.
Ah, yeah, the hand warmers. So whatever you spent on the hand warmers was your cost. Whatever people paid you at Phoenix Fair was your revenue. The only way to make profit is for revenue to be greater than cost. So this right here, to make a profit, revenue must be greater than cost. Because that means that the money that people gave you was more than the money that you spent. Which that math just kind of makes sense to me. So if we look at this situation of an applesauce company, their revenue is given to us by this formula. It's long, kind of looks complicated, do not be afraid. U is the number of units of applesauce sold, but we don't know what a unit is, guys. A unit might be a cup of applesauce. A unit might be a jar of applesauce. It might be a case of applesauce, or it might be a pallet. That might be what they call 1 unit. So, unit is just a relative, it's a placeholder word. Exactly. A unit could be a truck full. You never know. So, if the company's cost is $5,204,000, their cost for the year is $5 million. Now, that would include their electricity cost, the cost for the apples, the cost for any jars or packaging.
Feeding
like-
their workers.
Yeah, pay for their workers, gas for their trucks. So cost is everything that they incur. What values of U does the company make a profit? So to make profit, revenue has to be more than cost. So setup R is more than C. Revenue should be more than cost. Then we will, and I'm totally going to run out of space while solving this, set up 7,000 times U minus 9 plus 234,000 should be greater than 5,204,000. Don't forget your commas to hold your places.
Those are a lot of numbers.
That is
Bless you.
complicated.
Yeah, this is like real business math.
Really?
We just have to subtract that, then distribute that, and then
Hey,
add
I
that.
know you're B team captain today, but I gotta draw some cards because I haven't talked to enough people today. So Sam,
I
can you
just
tell
said
me
that.
what we would do first? I do agree. Your placeholder words, you were not specific, so I thank you for not being specific.
Subtract the 7,000.
Todd, subtract the what?
7,000.
Now the 7,000 is actually multiplying because it's right up against parentheses, so we can't do that one. What is just being added?
The 234.
Yeah, the 234,000, that's what we want to get rid of. So we subtract that from both sides. That will give me 7,000 times U minus 9 is greater than 4,970,000?
What you
Question mark? I'm not
I'm
certain.
gonna
Does it
check
work
that.
if you distribute first before subtraction?
Now you could, but I'm going to show you why I didn't. It's actually more complicated if you do that.
Yeah, that's what I'm doing.
So here's why I didn't distribute first alpha. You can, and that's totally fine. But if you don't distribute, instead of distributing, you could get rid of that 7,000 by just dividing it. Because remember, when we look at a distribution, we have the choice. You can distribute to multiply or divide to avoid multiplying. Now if I divide over there, I have to also divide over here. That will give me I'm going to have to move over here, guys. That'll give me U minus 9 is greater than
710.
710. Sorry, I'm ahead of myself. 710. Now what do I do on both sides to get the U by itself, Colin? What do I do to get that U by itself?
Take or add 9.
Add 9 because we want to undo that subtraction. When we add 9 to both sides, U will be greater than 719. So they need to sell at least 719 more or units in the year to make any profit. So unit 720 is the first money they actually make. Have a great day, guys. Try your homework, come back and give me feedback. Let me know what issues you face.
Bye, Mr. Hudson.
Bye, Colin. Have a good day.